All right, so let's look at 3-1. Units and conversions. As a matter of fact, let me go to my note sheet. All right, so we're looking at units and conversions, and we have 3 different countries have currencies A, B, and C. The ratio of currency A to currency B to currency C is 4 to 396 to 9. So it says use the given information to answer this part A through C. All right. So what they did was they gave us part of our proportion and they wanted us to use that to calculate the rest of the chart. So when we look at currency A, we have a 4-to-1 ratio. So in order to find these 2 boxes, the boxes that are under 396 and 9, we would set it up this way. So this is from A, and then it was 396, and then we'll have X. So remember, if we look at the box, got A, B, C, and I think it was 9. So that's that first row. So in order to figure out what this is, we will just put an X there, set up our proportion, and solve. And I believe it was either last class or class before we talked about setting the proportions. We use cross multiplication. Yep, yep. And so 396 times 1. Divide by 4. What, 99?
Mm-hmm.
Oh, somebody said, All right,
Yeah, I did it on the calculator real quick, just so I can follow. You know what I mean? So when I do
Yep.
my homework, I'm not like, okay, you know what I mean?
Yeah, you're fine. So, questions on that?
Mm-mm.
So for the next one, you do the exact same thing. Let's see if we call this one Y, just for clarity. Good. Cross multiply again. 4Y is equal to, well, just 9. Divide by 4. Y is equal to 9/4. So I believe 9/4 is good enough and you don't have to convert it to a decimal. Matter of fact, we'll go check. Before I go back to the homework sheet, questions on what we did there.
No, that was pretty simple. But like, let's say they do want a decimal.
Well, I'm about to go back to the sheet
Okay,
now and just make sure. I believe the fraction is good enough, but we'll make sure.
very cool.
hmm Just giving people a chance to finish copying. All right, let's go back. So, come on, 99 and yeah, so the fraction was good enough. All right, so now the other 2 spots. Let's go back to our notes. So they give us a 1 right here and then an open box right here. So what we would use now is this relationship as our standard. Last time we used 4 and 1, but to figure out the next row, we use 396 over 1. Now, if I want to find this one, I can call this what? M? I don't know. Just call it anything. Matter of fact, I'll use A. Call this one B. So then I would do 4 over A. So I'm using 396 over 1 and then 4 over A to figure out what that one would be. Cross multiply. Once again, once you set up your proportion, that's all we'll do is cross multiply.
Right.
That's 396A equal to 4. Divide by 396.
Okay. Yeah.
That should be 1 over 99. Then the other one, 9 over B, still using 396 over 1 as our standard for row, for the second row. And then cross multiplication. Divide by 396. That should be 1 over 44. All right. Problem with those two.
No, the only difference is we just kept the 1, right?
Well, yeah, the difference is we use 396 and 1 here before
Right.
we use 4 and 1. So it just depends on which row you're trying to calculate.
Okay.
And then the other one, when we get to the third row, the 1 is here under the 9.
Okay.
So we would try to figure out rows A and B. Well, it'd be
Right.
columns A and B in this third row, but we would be using the standard 9 over 1 because that's the ratio that we have.
Okay.
Yeah. So 199, 144. All right. So, and we can go do the last one. We got 9 over 1. As I mentioned, that's our standard ratio. And so we'll do 4 and 396. Okay. So they said just calling them another variable.
Okay.
And we would cross multiply. Divide by 9. All right, questions before we go to the next one. All right. All right. So use the given ratios to find conversion factors. Okay. Let's look at how we will convert. All right, so looking to convert measurements, let's see. Start off with a few. All right, so just starting off with a few measurements. All of your measurement conversions will be the same. And let's do this. Let's say US measurements right now, because we're gonna go to metric in a second. So these are US measurements. Metric, used all around the world, everywhere. US measurements, for the most part, used here in the US. Guess we have to feel like we're special. Um,
Right.
I'm pretty sure they use them, other places, but they're called U.S. measurements because, I guess we don't feel like converting. I don't know. All right, so just starting off with a few. These measurements are the same everywhere. So even if you can't find them in the book, if you don't know what they are, you gotta do is ask Siri, Google, Alexa, somebody. One of them people will tell you what these measurements are. They are all the same. They don't change. So 12 inches in the foot, 36 inches in the yard, 3 feet in the yard, 5,280 feet in 1 mile. So how will we use these? Let's say if I want to go from, let's go 5 feet to inches. All right. First thing we can do is set up 5 feet as a fraction just by writing it over 1. And we're going to multiply this by another fraction. That fraction is determined by the conversion factor that deals with feet and inches. So I can use this ratio or the relationship of inches to feet one of two ways. I can either write 12 inches over 1 foot or 1 foot over 12 inches. Same two things, but one's over top of the other and vice versa. So what dictates which one I use is this right here. If I start off with feet or if I have feet on top, then I need feet down here. So just like when you have your fractions and you want something to cancel out, it has to be in common with the top and the bottom. So if I have feet up top, I need feet down bottom. So that means I will use 12 inches over 1 foot. All right. So what that allows to happen is for our feet to cancel. Feet over feet will cancel. And it would leave us in inches, which is what I wanted. And now I can just multiply across. 5 times 12 is 60. 1 times 1 is 1. And that's just 60 inches.
Okay, that's not that bad. But when you were writing everything, I was like, oh my God. But that's not that bad. Okay.
Yeah.
Okay. How do you remember all of your formulas? Like, you know what
The
I mean?
conversion factors?
Well, just everything in general, like when you see a math problem.
Oh,
You know
because
what I
I've been
mean? Like,
it,
how do you, just so I,
mhm.
you know what I mean? To remember a formula or something. Like, what's the easiest way to remember it? Because math is like tricky, you know?
Right.
So, like,
Really it's about repetition, to be
okay,
honest. Yeah,
okay,
and I always try to warn people, don't take what I'm doing and think that that's how you're supposed to do it, because
right.
this is what I do, and I've been doing it for 16 years.
Yeah,
You
yeah,
know what I mean?
yeah,
So I'm doing it all day, every day for 16 years. I should be okay with it. If
right,
I'm not, then we have a problem. You
right,
know what I mean?
right.
So, you always, you always try to make sure people taper, their thought process. Don't measure yourself to me.
Right,
It's just
right.
like me coming into your profession and be like, dang, man, you can really do that well. And then I
Yeah.
shortchange myself.
Right.
Now, if I'm not a hairstylist, I can't look at somebody's
Yeah.
head and try to do that just
Yeah,
any
yeah.
old kind of way. So yeah, it's really about repetition, and that's the only reason why this stuff comes to me just naturally, because like I said, I've been doing it
Do
for
it all the
16
time.
years. Yeah, I
Yeah.
do it all the time. But repetition though would be the way that you get comfortable with these things. And a lot of times, since most people don't like math, they don't want to put the repetition in.
Yeah,
It,
yeah.
you know,
So
yep,
it's
yep,
essentially
yep.
just practicing those
Mm-hmm.
formulas so it
Yep,
comes easier.
yep. That's all it
I
is.
know math is just not exciting to me, so I'm sure everyone feels the same, but like, but okay, just really just practicing it, I guess.
Mm-hmm. That's all it is. All right, so let's go from inches to feet just to make sure we're okay with that thought process. And so, first thing we do is set up our 20 inches over 1 foot. We're going to multiply that. We'll use the same conversion factor because that's the one that deals with inches and feet. But this time, inches will be on the bottom. All right, so I want my inches to cancel. Now, when I multiply across, I have 20 over 12 feet. And depending on what my math lab want from you, you can either leave it in fraction or write it in decimal form. If we're going to do fraction, fours will cancel. 4 times 5, 4 times 3. And since they left the other thing in fraction, we'll leave this in fraction as well. And that's that. All right. So let's see. Let's see if I have. Mm, don't do 8,000 yet. I don't know if I want to do 8,000. Mm, mm, mm. Yeah, let's do that. Let's go 815, 840 feet. I want to know how many miles that would be for us. All right, set it up. And the conversion factor for feet to miles is that 1 mile is equal to 5,280 feet. Measurements of feet will cancel. Multiply across, that's 15, 840. over 5280. And that'll be 3 miles. All right. Questions on that so far?
No.
All right, let's see what the next one. All right, here it says use the given ratios to find the conversion factors. Okay, so it says from gallons to quarts, multiply by what? So you want to go from gallons to quarts. And they give us the conversion factor. I think it was 2 gallons equal 8 quarts. Let me make sure I saw it right. 2 gallons. Yeah, they say 2 gallons, 8 quarts. So that means I'm starting off. If I'm going from gallons to quarts, that means I'm starting off in gallons. It doesn't matter what number. I'm starting off in gallons. So that means I need to multiply whatever it is, X gallons, by 8 quarts divided by 2 gallons, right? Because I want my gallons to cancel out.
Mm-hmm.
So they ask us, what would we be multiplying by?
Mm.
And that would be 4, right? 8 divided by 2. All right, make sure we're okay with that.
Mm-hmm.
Everybody straight. Um, all right, gallons to quarts. Not gonna mess with the concepts. Oh, come on, get out of here. All right, so we'll go to the next one. Kilograms of pounds, so it's the same thing. Okay, let's go to the next one then. Okay, this is a good one. Okay, next one. Decide whether the following statement makes sense or does not make sense. Explain your reasoning. I drove the speed of 35 miles for the entire trip. Anybody want to help us out there? Whether it's right or wrong, make sense, don't make sense, I should say. I drove at a speed of 30 miles for the entire trip.
A.
Statement makes sense because it's reasonable for a person to go on a 35-mile trip. You're missing a key word.
Entire.
Hmm?
Entire trip is that where I'm not looking? Okay.
Nope. Before you get there.
Jeez, you drove that long for the whole trip? That's crazy. Didn't increase or nothing.
Look at B.
The statement does not make sense because miles is not a unit of speed. Oh.
Yep. It didn't say miles per hour.
Uh.
Just said drove a speed of 35 miles. That's distance.
Okay.
Yeah. So you would actually have to say 35 miles per hour if you're going to say it as a speed. And now if they want to say I drove 35
Yeah.
miles for the entire trip, you know.
Right.
then that would be a distance. But yeah, so you just have to be careful with the words.
Okay.
All right, 6 feet to inches.
Okay, what we did before.
Mm-hmm. Pounds to kilograms, but they gave you all the measurements. It's the same thought process where we got pounds to kilograms.
Okay.
Let me see, 4, 5, 3, 6. Now also notice here, they got 1 pound is equal to 0.4536 kilograms. 1 kilogram is equal to 2.205 pounds. You can use either one of those conversion factors. They are the same relationship. If I were to divide the 0.4536 to the other side, that will give me 2.205. So they are the same conversion factor. It's just that one is set up for kilograms, the other one is set up to find pounds. But you
Right.
can use either or, and you will still get the same answer. So looking at 9 pounds to kilograms. And so this is a US measurement to a metric. And we need to talk about metric in a second. Oh, where are we at? So we do 1 pound to 0.4536 kilograms. Make sure my number is right. 4536, yep. So put the pound down bottom and then 0.4536 kilograms. Pounds will cancel. And 9 times 0.4536. It's kilograms. All right. Problems and problems.
Mhm. Seems like it's the same steps, just the difference is multiplication or division.
Yep, that's all it is.
Okay.
Now, when we look at the metric, then it's a little, all we're doing is moving the decimal to the right or left. If we
Okay.
just stay in metric, but if you're talking about, right, your conversion factors, you
Uh-huh.
absolutely are correct. All
Okay.
right, so here, Celsius to Fahrenheit. I thought I saw metric somewhere up here. Um, see, these are just different ways of them giving you, there was Celsius again, just different conversion factors.
Right.
I thought for sure I saw metric somewhere. Well, I guess I don't have to worry about it if they didn't do it.
No, I feel like it'll still pop up in mine. Metric, I'm gonna be like, oh my god.
Well, I'm showing you the problems right now.
Okay.
Maybe I'm thinking about another assignment. Yeah, I might be thinking about another assignment. So let's go through these formulas right here. Oh, there's 3-1. Maybe I'm thinking about 3-2. I don't know. But yeah, it shouldn't pop up if if it's not
Yeah.
popping up right there.
Okay. Okay, cool. Yeah.
So let's go Celsius to Fahrenheit. Oh, did I do it wrong? No, I have failed. Oh, that's wrong. That's the wrong order. So it should be Fahrenheit to Celsius. And then this one is Celsius to Fahrenheit. All right, so just dealing with temperature, going from Fahrenheit to Celsius, Celsius to Fahrenheit. So if I have Fahrenheit, which is F, I plug it in and that will give me the Celsius. Or if I have Celsius, which is C, I plug into this formula and that'll give me the Fahrenheit. So 85 degrees Fahrenheit. So I'm going to plug it into the formula. 85 minus 32 divided by 1.8. I got 4 repeated. I'm going to see if they want the decimal or a fraction. Oh, it says round to 1 decimal place. All right. So 29.4 degrees. All right. Questions on that first one? So they give you Fahrenheit. They want you to convert it to Celsius. They give you Celsius. They want you to convert it to Fahrenheit.
Okay, just plugging it in.
Mm-hmm. So here we have 70 degrees Celsius. So we use the other formula. All right.
Mm-hmm.
So 1.8 times 70 is 126.
Okay.
Plus 32, 158.
Okay, not that bad. Only because I'm doing the problem too with my calculator. I'm still thinking about the hang of the scientific calculator, but still, you know what I mean?
Mm-hmm.
So I'm just punching into my calculator also.
Right. Dollars per form. Okay. Let's look at the next one. And you know how I do. I'm not going to do all your problems.
Right.
So this will put us at halfway. But we'll see. Because then some of them are repeated.
Right.
So go back. Yeah, so let's
Mm-hmm.
look at this. You arrive in Montreal with $600. How many Canadian dollars can you buy? So notice how they give us the chart.
Mm-hmm.
You got Canadian dollars, so the British pound, European euro, Japanese yen, Mexican peso. None of those matter right now. All we're looking at is Canadian dollar. All right. So now in your assignment, you know, when you get to this problem, you may
Yeah.
be asked about the British pound. You know what I mean? So
Yeah,
they may
different.
change the words or
Yeah.
change the numbers, but they do have the right because they give you all the conversion factors. So right now we're just looking at Canadian dollar. Notice they give us dollars per foreign, then foreign per dollar. So that's the same thing with doing inches over feet versus feet over inches. So you have to figure out which one you're dealing with. So which one you want to do. Now your foreign is the Montreal,
Oh.
right? And then the Canadian dollars is what you want to convert it to. So we're actually looking at, well, let me write it out first so we can make sure that we see. So we're looking at $600 So Montreal dollars. And we want to go to Canadian. All right. So to Canada, I said Canada. So to Canada, Montreal is going to be foreign. They said a 1. And like I say, we want to convert it to the Canadian dollar. And so we need a foreign to be on the bottom. So that means we're looking at dollars per foreign. And I don't know if I emphasized it in this class or not, it might have been another class, but per and that division sign are the same thing. So when you say per, that's dollars over foreign. So let me go back and see what that conversion factor was. Dollars per foreign, 0.7834. All right. Questions before we go any further? 600 times 0.7834. So we want that foreign dollar to cancel out to leave us in Canadian dollars. Multiply those two together. That'll be 470.04, excuse me. Canadian, there you go. And that should be that.
Not that bad.
Did I write it wrong? 2 decimal places. Hold up. And did I? I'm trying to make sure my decimal's right because I typed it in. And did I use the wrong one? Dollars per foreign. 7834. 600 times 0.7834. It shouldn't be this. Let me see. 6. Okay. Oh, I'm looking at something. I must have put it in wrong. Dollars per foreign, right? 0.7834. Dollars per foreign. Do I have a mix? So this 74784, I use the right conversion factor. I'm trying to see why dollars per foreign, Canadian dollars per foreign. Because really the way they have it set up, the 0.7834 should go down here. But that's not how I'm reading the chart. So I'm trying to make sure I'm interpreting this chart properly before I, because the 400, not 400, 600 times 1.277. So dollars per foreign. So they must be calling, they must be interpreted it the other way around. Okay. So I guess they're calling the measurement that you're in the dollars.
Mm-hmm.
So basically, they must have it the other way around as far as how I was interpreting it.
Right.
So this is the dollars, and this is considered the foreign. So they're looking at it from the other way around. Didn't mean to do that. Yeah.
Okay.
So with that being said, let's reset how we're looking at this thing. So the initial, I'm thinking that they're looking at it from the Canadian perspective. I want to convert this, but they're actually looking at it from the person coming in from Montreal.
Mm.
So the one that you start off with is your dollars,
Okay.
and then the other one, whichever one you're trying to convert it to, is your foreign. So going back to the homework. So your currency exchange rates, the table follow. So you arrive in Montreal with $600. Oh, that's why I messed it up. Okay, you arrive in Montreal. I'm thinking that you came from Montreal with $600 and you were going to Canada. Okay, so yeah, that's where I messed it up then. So the Montreal is the dollars and the foreign is the Canadian. You want to convert it. So you can use either one of these. I use the 0.7834.
Mm-hmm.
And so 0.7834 dollars, and that's per core. Let me settle this. One foreign. I don't know why I didn't give myself enough room. So, all right, so 0.7834 dollars to the one foreign. And that foreign, remember I said in our case we were looking at Canadian or Canada dollars. And so that's how we would do it. And so this would cause us to divide instead of multiply. Was that someone about to say something?
No, I was saying, oh, okay.
Oh, okay. All right. Yeah. So I had, like I said, I interpreted the graph, the chart, wrong. But sometimes that happens, and that's why you actually have to do the problems, you know?
No, yeah, definitely.
You know, and see what they want, see what they're asking of you.
Yeah.
You go into these, and so, and to see how they set up these charts. So that would actually be $765.89, and that would be in Canadian dollars. All right. So what else we got going on here? 5 gallons to quarts. Already did that. Already did kilometers to pound liters. So the rest of them are doing the same thing we did: Celsius to Fahrenheit, grams, and all the good stuff like that. So the only one that might be a little bit confusing is this chart that I just finished messing with. Before we do anything else, questions on conversion factors using the formula Celsius to Fahrenheit, pounds to kilograms, whatever the case may be. I did that one already. Yeah, did that one. Version K. That one. Yeah, that's pretty much it for that. Questions. Somebody want to see anything else out of that section?
I think
Or
it's pretty good. Either divide or multiplication is really.
yeah, yep.
Um, okay.
We got was 1023. Somebody said they want to do another section. All right. Then I hear that. Then somebody said they want Miss Gallup. I think you said you wanted to do another section.
You sure? You
I
don't
think that's what I thought. That's what I heard.
want.
You're right.
All right. Let's see. Let's see. Let's see. Where did it go? Mm, 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 mm. All right. So that was 3-1. See, do we want to do 3-2 today? See what 3-2 is talking about. Oh, okay. Here you go. Yeah, I know I saw some metric systems. So Miss Ross and the other theory here it goes right here.
Okay.
Yeah, so we'll talk about that. And let's go to where did my notes go? All right. Metric or metric system. All right. So when it comes to the metric system, these are the basic ones, but they can get very large or a lot larger and a lot smaller.
Hmm.
We got kilo, hecto, deca. Then we have our bases, grams, meters, liters, and I'll write some more on that in a second. But it depends on what you're measuring, would dictate whether you use gram, meters, or liters. Got your deci, centi, or whatever, and milli. Abbreviations, KHDA for deca, and like I said, GML for your bases, depending on what you're measuring,
Right.
D, C, and M. And so either one of those abbreviations can go in front of any of your bases. And once again, I'll show you that after we finish talking about the chart. Then you see your value 1,000, 110, 1, 1/10, 100th, and then 1/1000. So, like I said, it can get very large, a lot larger than kilo. You guys, most of you have had experience with that already when you talk about gigabytes and megabytes and all the good stuff like that. Then it can get very small, like nano and pico and all the good stuff like that.
Right.
All right. So bases. Got your gram, meter, liter, GML, mass, length, and volume. So mass or weight, your length, and then volume. Then from there, you can put either one of those abbreviations or either one of those prefixes in front of your bases. So you do kilogram, kilometer, kiloliter, or milligram, millimeter, milliliter. So any one of those prefixes can go in front of your bases. All right, so there is an order when it comes to metric system, and the order matters. So if you notice, these are multiples of 10. You know, 10, 1,000, 100, 10, then 1/10, 1/100th, 1/1000th. So the order matters because all we will be doing is moving our decimal from the right to left. So the way we can remember the order is to remember that King Henry died by drinking, running out of room. I'll just bring it down here. Drinking chocolate milk. So kilo, hecto, deca, that's one of your bases, depending on what you're measuring. Deci, centa, and milli. King Henry died by drinking chocolate milk.
Oh, okay.
All right, so if I wanted to convert, let's go centimeters. So 968.7 centimeters to kilometers. I will look at my measurements on my measurements. Kilometers, hectometers, decameters, meters. So that's King Henry died by, your base is meters. Drinking, that's decimeters, chocolate, centimeters, and then millimeters, milk. So I'm in centimeters and I want to go to kilometers. So go there and I say, okay, locate centimeters and then the direction I want to go as far as to get to kilometers and how many spaces does it take or how many moves does it take to get to kilometers. So I'm going 1, 2, 3, 4, 5. So 5 to the left. So that's what I do with my decimal. Locate my decimal and go 1, 2, 3, 4, 5 to the left. And that would be your conversion. And whether it's meters, liters, or grams, you still follow the same process.
Right.
All right. So if I had wait, uh, so if I want to go 123.86, not meters, let's go decagrams to milligrams. So if I decide to set up my measurements, kilograms, hectograms, decagrams, grams, decigrams, centigrams, and milligrams. Before I do that, so you start off in decagrams and go 1, 2, 3, 4 to the right. Take your decimal, 1, 2, 3, 4 to the right. And just like before, use zeros as placeholders if you don't have enough spaces to cover the movements. So So 1,238,600 milligrams.
Yeah, repetition's needed for these ones, but it's not that bad, but it's definitely you know what I mean?
Mm-hmm. Yep. All right, so let's look at a few problems. And I just pulled it up. Homework. All right, find the scale ratio for the map described below. 1 millimeter on the map represents 1 meter on the ground. So let's go back to our notes. We're looking at going from 1 millimeter to a meter. Let's go back here. Well, I'll just write it just so I don't mess up those. All right. So we look at what we have here. We're talking about a meter in comparison to a millimeter. That's 1, 2, 3. So if we're talking about 1, there should be a 1, 2. If I look at the number 1, and I will move it 3 spots to the right, 1, 2, 3, that will give me 1,000. Should be a 1 to 1,000 ratio. Talking about meter, comparing it to a millimeter. I don't think I showed the screen. So yeah, 1 to 1,000. All right, so we got 1 centimeter, converting it to kilometer. So we got centimeter to kilometer. So 1, 2, 3, 4, 5. Got 5 zeros that we want to add to that. And So you would take that 50 and add 5 zeros behind it.
Mm.
You know, that goes back to what we just did.
Yeah.
You know, just moving the decimal.
Right.
Yeah. Centimeters to kilometers. 1, 2, 3, 4, 5. So that's where I got the 5 from. So we had 50. So I added 5 zeros. 1, 2, 3, 4, 5. And so that's what I put in the box.
Okay. Okay, and 3.2 only has 6 problems in it.
Yep.
Okay.
Yep.
Okay, not bad.
Yeah. So, and it's the same thing going from millimeters to meters. Let's see, the table on the right, give distance, calculate the scale size on planet. So Mercury, kilometers. Yep. So you'll convert millimeters to kilometers in both cases. So you're talking about millimeters, kilometers. 1, 2, 3, 4, 5, 6 zeros. They want to put all that in there. From sun, meters, 1, 3, 5, 4. So we have 480 kilometers. You want to convert that to meters? That's what I did. 6 zeros. Trying to make sure I'm doing what they asked before I let you guys go. Diameter is 4800 kilometers. Convert it to meters. Move it zeros. Mark through this. 0.5. Oh, round it to the nearest tenth. Top. Pay attention to directions. Okay.
Yeah, yeah, definitely. I do the same thing. I'm like, wait, what? Oh, that's what it meant. Jeez.
So yeah. So that's what got me. So yeah, just pay attention to the directions and you guys will be all right.
Okay.
So try the stuff out. When it comes to, like I said, the meters and suppose the entire body are 100-meter long, 4.5 billions. Yep. So scale of 1/24. So that's the measurement there. Yep. So as always, just try it out. If I look through some more and I want to, and I think it's a
Right.
little different than what we talked about, we can do it next class. Because
Okay.
yeah, we run out of time. So, like I said, check it out
Yeah.
and see if you run across anything that you want to see, that you want to see. If not, I'll look through it again, see if there's some other ones that's different than what we talked about, and then we can do some more next class. If not, then we'll go ahead into 3.3.
Okay.
All
Sounds good.
right.
When do you think like our midterm will be? Just so I have in my head, you know what I mean?
Oh, you said you want to do the midterm next class?
No. I'm nowhere near it. But like typically, like I know we're getting into October, so I know it's usually like middle of October or something like that. You know what I mean? I don't know.
Yeah, it'll be something like that. Let's look at the dates right now. We're looking at September 30th, which is today. I guess no earlier than the 21st, or You
no
know,
later.
that's like 3 weeks from now,
Okay.
October 21st.
Okay.
Yep. Probably do it like that, October 21st.
Okay.
So I guess on the 7th, next Wednesday, probably be the cutoff because all of chapter 3, I mean all of 1, 2, and 3 will probably be on it. Probably
Right.
do it like that.
Okay.
Yep. And yeah, go
Okay.
from there.
Okay then.
Say that again now.
I said okay then.
Okay, all right.
He's excited for it. I can feel it. Same here.
So we'll look at the midterm
Okay.
in October 21st. And let me make sure of something else. Chapter 3, so that's 4, 5, 6, 7. What up, 4, 5, 6, 8, 9, 10. Okay. So, we'll see as far as the rest of the class. We may not get to all this content, the rest of the content. But so our midterm, we can just put it on 1 through 3. And then the last test that we do, the final test, will be on everything from the midterm to the end of the semester.
Okay, so like a collective bunch. Like the one
just from the midterm, not from the
okay.
from the midterm to the end of the semester.
Okay, so like chapter 4 to chapter 8 or something like that.
Right.
Okay.
Yeah.
Okay.
All right.
Okay, cool.
Questions? Anybody else before we close out?
No, that was definitely one question I had. That's pretty good. Okay.
All right. Now, that's not, once we close out chapter 3, of course, we're going to keep talking about different, new things. So we're not going to stop at chapter 3 and be reviewing from, all the way to the, I'm just giving you guys, an opportunity and time to, to get, ready for that.
Yeah.
And everything, that midterm. So, but we most definitely would have talked about things in chapter 4 before the midterm, unless y'all want the midterm to be earlier.
No.
Or something like that. So,
I'm to like prep. You know what I mean? Like,
right. Yeah, because some people, they don't want to talk about new stuff while they got a test coming
I
up.
get
You know
that.
what I'm saying? So,
Yeah, I get it.
yep. So we'll do it like that.
Okay.
And the 21st, we'll be looking to have it. I will post a review as well.
Okay.
I just need to remember to do it. So if you don't see one, let's say the week before, feel free to remind me to post it. It's not a big deal. I encourage reminders.
Okay. Yeah, definitely. You got a lot going on and everybody else too. So definitely.
Yep. So outside of that, you guys have a good one. If you have any questions, feel free to let me know. Shoot me an email, Zoom, all that good stuff. We can set it up.
Okay.
All right. So
all right.
everybody
Well, thanks
have
for
a
your
good
time.
one. All right. Not a problem. Thank you guys for coming.